All right, so for 4-7, day 1, we're going to be graphing some quadratics here. So we're going to be looking at them when they are in standard form, and the highest power is going to be squared, so to the second power. So our parent function is just x squared if we didn't have anything transforming it. So let's take a look at what that graph would look like down here. And if we kind of plug in some values into our x squared so we can get some coordinates here, it would be -5 squared. I'm going to leave off the f of x for these here. -4 squared and -3 squared. So when we do that, if we're plugging in -5, that's my x, and the output, -5 squared, is +25. And then going through here, -4, 16, -3 for your x, plugging it in, and you get 9. And then these are kind of already done for us in a sense, but -2 and -2 squared, 4, -1 and -1 squared, 1, 0, 0, 1 and 1 squared is 1, plug in 2, 2 squared is 4, plug in 3, and 3 squared is 9, plug in 4, and 4 squared is 16. So if we went ahead and plotted these coordinates over here, it would look like this. So take a second to do that. And then we'll draw our lines. So here's what it should look like. And this graph is a U shape. And its domain from left to right is -infinity to +infinity. And its range from as far down as we can go, which in this case is 0, all the way up to +infinity. And our vertex, so our vertex point is down here at 0, 0. So that's our original parent function. So keep that shape in mind. And let's go ahead and practice graphing that on a couple more different graphs, because you are going to be graphing this a lot. So here's the trick. What you want to do is start at 0, 0 and put a dot, because we know that's our vertex. Then when you go to 1, think about what's 1 squared? Well, 1. So we're going to go up to 1. Go to 2. What's 2 squared? 4. So go up to 4. What's 3 squared? 9. Go up to 9. What's 4 squared? 16. Go up to 16. What's 5 squared? 25. Go up to 25. Did I miss 25? Here's 25. 6. 6 squared? 36. Go look at this one pretty closely. 36. And 7 squared? 49. All the way up. Then what you're going to do is repeat that on the same side. So -1 squared, 1. -2 squared, +4, etc. And it will make that same design, or that same curve, on the left that it did on the right. So what I want you to do is graph on these 3 graphs, doing that same pattern, and then check your answer when you're ready with what I have. All right, so let's check your answers. Should look like that. Again, we only got part of that left side there, but we should still have that. And then down here, that's what those should look like. So again, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, etc. Doing those perfect squares. All right, let's flip to the next page. And what we're going to do is, what if it's in standard form? How would we graph that? Well, the quickest way is going to be to find what we call the value that we're going to start with by using -b/2a. So remember that formula, kind of? So we're going to do the opposite of b/2a to find our vertex, in a sense, and then we'll find the other points, so that way when we graph it, we'll have our bottom vertex point, and then we'll start to get that U shape a lot easier. So opposite of b/2 times a would look like that. So it's +4/2, which is 2. So this is the value that we want to put here, 2. Now we're going to go down from there. 1, 0, and up from there 3, 4. These are our values we're going to plug in for x, and we are going to see what we get for y, and then we can go ahead and graph those coordinates to get our U shape. So what we want to do is just plug these values in for x and then simplify. Now be careful when you're simplifying. You want to make sure that you're doing order of operations first. So that means exponents are going to come first, and then, so we've got 0 squared, we're going to do that first, so 0. Then we're going to do multiplication next, so 0, and then plus 3. So this is going to be 0, 3. And then we want to do, for the next one, 1 squared, so 1. And then we want to multiply here, so negative 4. So 1 minus 4, which is negative 3. And then minus 3, which is 0. And that's always our output, because our input is the x. So if you want to fill in all your x's first, you can over here. You know what those are. We're just looking for that output. So here would be 4 minus 8, which is negative 4, plus 3, which is negative 1. 9 minus 12, and you could kind of write it below here if you needed to, 9, and then multiply these two, so minus 12 plus 3, and then work your way left to right if that's easier. So that's going to be negative 3 plus 3, which is 0, and then 16 minus 16, which is 0, plus 3, which is 3. So now we can plot these points. Go to 0, 3, put a dot. Go to 1 and stay at 0. Go to 2, go to negative 1. Go to 3, stay at 0. Go to 4, and go up to 3. And up, there's our U. I can see it. So we can go ahead and draw from there. It kind of looks like a V, not very curvy. There we go, a little better. All right, so go ahead and try number 2 on your own and check your answer when you're ready. So remember that this middle value should be negative b over 2a, and so you should have 1 here, and then 0, then negative 1, then 2, then 3, plugging those values in to get your coordinates, and then graphing. All right, so what we're going to look at next is vertex form. So this should kind of feel like review from the last section of 4.1. Remember, if it's positive, it's going to be opening. Or if A is positive, it'll be opening up. Down, if A is negative. The vertex is H and K, where we're pulling here. And then the axis of symmetry is what X equals. That would be the vertical line that goes right through that vertex, which is why we use our X value, or our H. And remember that H is always opposite thinking. So let's go ahead and do a couple of examples. Again, this should feel kind of like review from 4.1, but our vertex, it's easy to see when it's in vertex form because we just do the opposite of this number and keep the outside number. So 4, negative 6, which means that our axis of symmetry is x equals 4 because we already have our x right here, 4. And this one opens, we look to the A, positive, so it opens up. And then we can see what's happening. Since we're opening up, we're not a reflection. But this 2 in front, remember that that does mean that we have a stretch by a factor of 2. This 4, opposite thinking, so we're really moving right 4 units to the right. And then the number behind, 6, we're really moving down 6 because it's a negative. Let's do one more. So over here, vertex opposite of the inside, so negative 3. Keep the outside, 4. Axis of symmetry, x equals negative 3. And this one, since there's a negative in front, means we're going to open down. So we do have a reflection since it's opening down and there's that negative in front. We have a 1/4, which means it's a compression by a factor of 1/4. Then inside here means not right 3, but opposite thinking, left 3 units to the left. And then this 4 behind there is up, moving us up 4. So try these next 2 on your own and check when you're ready. So check your vertex, your axis of symmetry, how it opens, and then check your transformation information, see how you did. That should be review from stuff we've already done before. All right, the last thing we're going to look at is actually plugging it back into Vertex Form when we're given the vertex. So I'm going to go ahead and just write our f of x out here, out front. So we're making it f of x. What does it equal? All right, so you could put your parentheses in there if you wanted to, and your squared so you didn't forget that stuff, but I'm going to kind of do it as I go. So this goes inside, and we want to make it opposite. So it should be x minus 2. Don't forget your squared because we're talking about quadratic equations, and we know that those are squared. The next thing we want is a 7 out behind there, and it should be a plus 7 because we keep that same sign. And there's no transformations to make it a reflection or a stretch or compression. So we are done. Take a look at another one. Let's take a look at number 3 together. So this one, we want to put this number, the x, back in, and we want it to be opposite when we put it back in. So it should be an x plus 1, and we want it squared. That's the part we tend to forget. Do we need to put the plus 0 behind here? No, you're right. We don't have to put that. So now we go to our transformations. Reflective means I need a negative out front. And then compressed by a fraction of 1/2, that means that 1/2 should be out front with that negative, but behind the negative. So go ahead and try 2 and 4 on your own and check when you're ready. All right, let's see how you did. Should have a negative out front, an x plus 3, opposite thinking, and then a plus 4 behind. Don't forget your squared. Then for number 4, we should have a 5 out front. We don't need parentheses because we don't really put that 0 in there. We don't put a minus or plus 0. We just have x squared since there's nothing inside. And then a minus 2 behind the x squared. All right, hopefully you did well. If not, make sure that you circle any that you have questions over, or maybe write some questions at the bottom of your notes packet.